That's one of the cool things too. If you create a playlist and as your stuff is
because sometimes it's a little difficult trying to find what classes.
Right.
Yeah.
Now, if you notice on the web page, you're gonna see only one video, right? But in that top right corner, right, you click on that and it'll give you a library of files that's in that playlist.
I had to use that like last week, but
It helped?
yeah, it's definitely helped.
Okay. Well, see, and I'm glad, that it does help. Because another guy said the same thing, Because you don't want to fail people. You want to help them any way you can to help them to make a better grade in the class. And sometimes you just can't be the class.
Well, the problem is now that I want my other teachers to do it too,
Yeah.
So this is, okay, I'm looking at it now. It has from 121, 128, 130, and
Right.
24.
Okay. Right. And it won't
This is 1923, right?
Right, that's right.
Okay.
And they got chapter 1, chapter 2.
Chapter 1 and 2, chapter 2A, chapter 2B, and then
Right.
chapter 2.
Right. Now that 1A, 2B, and 2B, that was the same day. Remember it kept stopping?
Yeah,
And all of a
okay.
sudden now it streams the whole hour. So, all right. So now let's go to the SYL site. Let me see how good that. Does the page look? Does it look good up there? Because they can't see the top. I'm gonna have to figure out how I'm gonna get it to where they can look at the top and see it in a clear fashion.
If you want to see what it looks like, that's it.
Yeah, see this. I might need to cut the lights back on. Cause that's. Is that better?
It's going to take it a second to catch up.
yeah.
And this is at it right now.
Is it better or the same?
Well, this was like right before. I guess this is the same right now. Yeah, I guess it's.
Right, that's now. See, it's a little better, huh? Because it's lighter.
Yeah, I guess so.
Yeah.
It's a little cockeyed, but yeah.
Right. So I might need to get them to install a light. That's a. All right. So if we look down here on the web page at conversion, look here under these notes, conversion table and tables and instructions. All right. Let it come up. All right. So what you'll see is you'll see a the placement table for base 2, placement table for base 8, and a placement table for base 16. This is what we're going to be using in doing our conversions. Now, some people might say, well, and when I do give quizzes, well, Mr. Sylvester, can you put up the placement chart when we actually doing the quiz? Sometimes I put it up. Sometimes I say, okay, create it. Now, if you wanted to create the placement table, it's not hard, all right? What you do is, starting from the right, going to the left, whatever base you're working with, here we're working with base what? 2, right? You just 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, on and on and on and on. Now, then you just solve for it. Anything to the 0 power is 1. 2 to the first power, any number to the first power is the number itself. 2 squared is 4. You understand? And we move on and on. So that's 2 to the fourth is 2 times 2 times 2 times 2, which is 16. So you can create your table, all right? Base 8, same thing. We're working with base 8. 8 to the 0, 8 to the 1, 8 squared, 8 cubed, 8 to the 4th, 5th, 6th, 7th, and we can go on. And then you just solve. Any number to the 0 is 1, and to the 1 is 8, 8 squared, 64, and on and on. Base 16, same difference. 16 to the 0, 16 to the first, 16 second, third, fourth, fifth. Anything to the 0 power is 1. 16 to the first power is 16, 16 squared, 256, and on and on. So that's how you would create the table. So if I told you had to create it, the only thing you would probably worry about is getting your calculations correct, right? So Now, what we're going to try to do now is, if we look at this example, it says that these are the steps in converting a decimal to a binary digit, all right? Taking a decimal number and converting it to binary, okay? Everybody understand it? So a decimal digit has a possibility of how many different digits? Huh? Huh? No, I'm talking about just the digits, that valid digits in a number. How many valid digits, a combination of digits that you can use? 0 through what?
10 or 9.
0 through 9, because
I didn't understand what you were asking.
the digits, just the actual digits, right? Because in base 2, there's only what? How many digits that's valid?
1 and 0.
Which are those 2 digits, that's it, nothing else, right? So, in base 8, what are the valid digits?
0 through 8.
0 through what?
7.
7, because 0 is the 1. You got what I'm saying? Like 1, 2, 3, 4. So, just like with base 10, 0 through 9, but it's 10 digits, correct? All right, so it tells us, and like I said, you need to work through this several times to kind of get the gist of how to do it. Once you get it, man, it's a breeze. It says, okay, if I'm going to convert a decimal is a number in base what?
10.
Base 10, right? And we all work with base 10, right? We get paid in base 10. Our hours is calculated in base 10. We go to the store, we purchase with what? Base 10, right? So we should understand base 10, correct? Now, it says, given a number, a decimal number, and this here, given the number 49. Looking through this placement chart, right? Find the highest value that is less than or equal to that number, okay? So, looking at this table, what is the highest value that is less than or equal to 49?
32.
32, right? So you found that position. Once you find that position, you mark a 1 there, right? Once you mark that 1 there, now you need to subtract that column from 49, okay? So we subtract 32 from 49 and we get what? 17. Now it says once we subtract, if we have a remainder other than 0, we have to do what? Repeat that process, okay? So, now we have 17. Now we need to look through the chart and find a digit, or find the value that's a highest value that's less than or equal to 17, and that's what? 16. You put a 1, okay? So now, put the 1, you subtract 16 from 17, and you get what? A remainder of 1. So we're still not at 0, right? So now we have to go through the same process again. Find the value, the highest value that is less than or equal to 1, which is what position? The very last position. So we put a 1 there. Now it's important for us to what? Include
The 0.
the 3 zeros that goes in between, because that's just like, say, writing a number 1,000 and say I'm gonna take a 0 out, but the number gonna be the same. No, right? Somebody might write it as what? 100, right? So you got to have those significant 0 digits in them, all right? So the answer, 49 in base what?
10.
10 is equal to 110001 in base
2.
2. Everybody got that? Questions?
I don't get the base 2 part.
Base 2 is a 2-digit number. Remember, the computer turns everything into what? Binary.
Okay.
So it's 0s and 1s.
So we started out with like 300 and then be base 3.
No, the thing is, we could have 300, but to convert it to binary, we have to follow this step here to put it in this binary form.
So
Yeah.
binary just always be base 2.
Zero, thank you, that's it. Binary, 2. Binary is 2. By, 2. Right, 0s and 1. Yes.
So would that be 6 bits?
If you're looking at this, it's what? 1, 2, 3, 4, 5. Yeah, correct.
So how does that work? I thought they're gonna be like 4 or 8.
No. But you can fill in zeros. Yeah, you always can fill in zeros at the beginning. Just like when you're dealing with numbers, right? Right? Oh, well, let's say Dustin, you can put in the zeros to say, okay, when you fill out a bank withdrawal, it got, I know I can't never go to a meeting, but it got, comma, I can put all of this. Right? So you can say you always can put in those leading zeros to make it understood. Right? All right. Now, questions? Questions? Everybody got it? Okay, let me ask you this. Write down the number 75. All right, that's a base 10 number. I'm telling you, it's base 10. Convert 75 into a binary number. Following those steps. All right, convert 75 into a binary number. Follow the steps. Miss whatever, you got your pen and paper? Miss, you got a pencil and paper? Convert 75 to a binary number. So you're gonna what? Take 75, using that placement chart, find the value that's the highest value that's less than or equal to 75, mark your 1,
64.
subtract, right, put your 1, subtract, then go through the process all over again until you complete that process. All right?
What was the number? 72?
75.
75?
I want you to do it on the computer.
Oh no, I'm just doing subtraction. I know.
Okay. All right. You're just using a calculator on the computer. Okay. All right.
So it'll be the.
Yeah, but write it down. Go ahead and write it down.
Uh, 1001011.
Okay. All right. So let's see. Throw out a number. So 75. So what happens here? You place the 1 in what column?
64.
The 64 column. So that's what. So you know your number gonna be at least what? 7 digits long, right? So we put a 1 in the 64 column and we subtracted what? 64 to get what? 11. Now, find the highest value that's less than or equal to 11, which is what? 8. So I'm gonna put about 1, 2, and then a 1, right? So I'm gonna have 0, 0, 1. Put an 8 here, subtract 8 from 11, we'll get what? 3. Now, so looking at this, find the highest value less than or equal to 3 is what? 2. So we got a 0 here between that right there, right? So we put 0 and the 2. But then 3 minus 2 is what? 1. So what? The last one, we put the 1, right? So, who had given that answer? In base 2. What you got?
1001011.
Correct. In base 2. Everybody got that answer?
Yep.
Questions? Any questions? All right.
Why are we using base 10? Just
No, because see, base 10 is what we see, what we pretty commonly understand. Because like when we put a number in the system, the computer has to take that and what?
yeah.
Convert it.
But usually we would use 8, right? Or 8, 16 or whatever.
The computer does. Yeah.
That's what I mean.
Yeah,
Technically,
right.
you would have to convert it and then convert it back to us.
Right. Because we see the actual number. Right. Okay? All right. So now, no eraser. Oh, not big. So anybody have any questions? Questions? Let's take another. All right. Let's take the number, what? $15 in base 10 is equal to what in base 2? Man, I did it. Well, yeah, we'll do 15. Well,
Do 1 0 0.
huh? It'll be what?
1 0 0 0 1.
All right. You say what? 1 0 0.
It would be 1 1 1. I thought about it because it's 1 under 16.
Right. So it'll be what?
1 1 1.
1 1 1.
Right. You see, less than or equal to. Right. So what we do? We take 15. Go to the chart. Find the value that's higher value less than or equal to 15 is what? 8, right? So, we got 15, we put a 1. 15 minus 8 is what?
7.
Alright, so now, we look at the chart, try to find the highest value less than or equal to 7 is what?
4.
4, so that's right after the 8, so we put a 1, right? So 7 minus 4 is what?
3.
3. Then we find the highest value here, which is what?
2.
2, right next to the 4, right? And why is this Mr. 2? And then we got a 1, so it'll be what?
1 1 1.
So right, it'll be 1 1.
Let's start up a little bit.
Right. But I'm saying, you see how if the number's in a different place, it makes it throw the value off. It throws the value off. So you have to be wise. Anybody questions? Questions? Yes.
When are we ever going to actually have to convert it?
Listen, you may never have to convert. But I'll give you my experience, and like I said, a lot of times it's for like system programming, sometimes system debugging and whatnot. When I was in school, we had an IBM mainframe. I forgot what number it was. But what happens is sometimes, and we did COBOL and whatnot, and COBOL, what happens, you get a dump. Now what a dump is, it's like, it's some kind of exception error, you got something going on wrong, and it gives you an address. So what we had to do, for whatever reason, we had to take a certain number in that dump, at the beginning of that dump, and I think we had to subtract 4,800 from it. And that gave us an address. I think it was a hexadecimal address.
Oh, so it didn't translate back to the decimal?
Right. So we could take and try to find what line we had an issue with. So you see what I'm saying?
Yeah.
So sometimes it's for system maintenance and whatnot.
Right.
You got what I'm saying? So you got to know how to convert, what's going on, how, whatever.
Maybe
Right.
think that.
But just coding, a lot of times, maybe not.
So could there ever be like an issue with your processor that could cause like something like that?
Well, what can happen is sometimes you might get an error at a particular address.
Okay.
Now you like saying, okay, what's this number here? How, whatever. But it's an address, none the same in your memory. Now, based on you as a, tech or whatever, you can say, well, wait a minute. This is trying to violate user privileges, trying to go into system memory
Right.
rather than using the user's memory. Because that's what viruses do. You understand? Viruses pretty much go into system memory, and a lot of times they change things and do whatever and cause your system to go haywire. Like, you remember when you had those Trojan viruses make your system lock and all that? Yeah. It was able, like I say, low-level languages, you can go into those areas and do certain things. Right. So it's good to understand so you can know how and why and whatever. And with low-level languages, back in the day when we had assembler language, it's unlike the fifth generation languages now, you had to actually put something in a particular address. Know what that address is to go get it. So it wasn't like, okay, X equal 5. I ain't gotta worry about where it's putting it or whatever. I have to tell it the address. I have to know, go get that address. And you was dealing with hex and whatever and whatnot. So, and that's why they want you to kind of understand it. So when you're faced with it, you're not so frightened and like, oh man, I don't know what that is, how, whatever. You at least know, okay, this is a hex number. I know what to do, somewhat of what's going on, what I can do with it. All right? So now, that's base 10 to base 2, all right? And then, like you said, a lot of information is converted into base 2. You understand? So we should be able to understand that, right? All right. So now, that's one process you need to understand, converting from base 10 to base 2. But now, converting back from binary to decimal, base 2 to base 10, all right? It's a simple process, but you have to know the process, right? All it says is if I have a binary number, and a binary number should only consist of what digits?
0 1.
0 and 1. Now, just because of, let me ask you this. And this is a trick question, but you still, I want to ask you. If I wrote this number on the board, looking at it just like it is that a binary number, a decimal number, an octal number, a hex number, or what?
Binary. Oh, I guess it
Could be any.
Huh?
Unknown.
Unknown. Why? I didn't put the base. You understand? Now, as in our culture, in America, we understand when we see a number, it's normally is in what?
Decimal.
Base 10, decimal. But in computer science, just because you see the number 100 does not necessarily mean it's what? 100. You understand? You need to know the what? The base. Because if I wrote this, 2, what's that number?
4.
Correct. 100 in base 2 is 4. I mean 100 in base 2, right, is equal to 4 in decimal. Right.
Right.
Now you say, well, how did we get that? We got the example on the board at the top. It says if I have a binary number to convert to decimal, you take the number beneath the placement chart, starting from the right, going to the left, write out that number, and then add up the columns where it has a 1. Everybody see that? Simple as that. Now, why would we start from the right going to the left?
So that when you write your binary number, it's left to right.
Because if I give you a 20-digit number, then what happens? You might miss a column and say, oh man, I'm gonna just add a 0. You understand what I'm saying? You get to the end, or you start on this side, and you get close to the end and say, oh, I'm gonna just add a 0. Can't do that. But if you start from the right to the left, you know you hopefully won't run out because you always can add columns, right? But if I start from this side going that way, and I start midway, and I got numbers dangling here, I gotta start all over, try to rewrite the number. So if you start from the right coming to the left, your number's gonna always be placed on a particular column. And then you just add up the columns with the 1. All right? So, given that, let's look at this expression. Example. So it says, starting from the right to the left, plug in the numbers into the placement chart. So beneath the placement chart, and then add the values where the switch is on, which is what? 1. So look, 49 was equal to what? 110001. So let's take 110001 and add up those columns where it has a 1 in it. And you get what? 49. Everybody see that? All right? So, I'll write a number on the board. Okay? What is that equal to in base 10? 101101. What is that equal to in base 10? What you gonna do? Take the number, plug it in under the placement chart, starting from the right, going to the left, and then solve where the switches are on or where you have a 1. All right? So that would be what? Okay, say 45. So it's like 1, 2, 3, 4, 5, 6, right? So this position is what? 32, right? Plus 8, right? Which is what? Which is 40, right? Plus 4,
44.
plus the 1,
45.
45. Everybody see that? Everybody understand it? So that's how we got this value. 45. Okay? So this number in base 2 is equal to 45 in base 10. Okay? Alright. Now, alright. So what I'll do too after class, I'll post a quiz for you. Well, we can take it in class, but I don't see too many people. What I'm gonna do, I'm gonna post a quiz just from binary to decimal and decimal to binary, just those 2 steps. But we're gonna continue on with the octal, okay? But everybody kind of get familiar with binary to decimal, decimal to binary, okay? All right, so let's look at the other steps. These steps are not very hard either, but you gotta realize what you're doing, all right? We're converting from binary to octal, okay? We're taking a number that's in base 2 and converting it to base 8, okay? Base 2 and converting it to base 8. Now, what did it say to do? What you do, they was given this number, okay? Given this long number in binary, all you simply do, starting from the right, going to the left, and break it up in 3s. Once you break it up in 3s, you solve it for the decimal value. And that's your octal value. So, let's look at this number. We got 100, 101, 010. All right? What is that number in octal? So what you do is, starting from the right, going to the left, divide. 010 divided, 101 divided, 100. That's the last 3, right? But what if a number has a 1 in the front of it? It's left out by itself. What would you do? If you was confused, just add 2 zeros in the front of it. So it'll be 001. Right?
You're saying if the number is
One digit larger. So if it's a 1 digit larger, it had a 1 in front of this.
right, so 3 couldn't go into it evenly.
Right, so you do a divide, then you do what? 1, but then what? 0. You're not taking the value away, right? Because the zeros is in front.
Right.
But it's keeping you understanding that, hey, these are the 3 digits. You got it? Or even if it was 2 digits, say it different, just add 1 0. All right? Everybody got that? So, to solve this, look what's happening. Because you got to keep your numbers in order. The first one is 100. 100, put under the placement table. What this equal to? 100 is equal to what?
4.
4, because what? All you're going to do is add up the what? The switches that are on. 101. 5. 010. 2. So what? 100101010 in base 2 is equal to 425 in base 8. I mean 452, my fault, in base 8. Alright? Now, you might say, well, Mr. Professor, why did you divide it by 3? Okay? Ask you again, what's the largest digit that can be used in base 8?
7.
Okay? what's the largest digit in binary? When I say the largest digit, well, what's the largest digit in binary is a what?
1.
1. So if I put 111 here, what's my answer gonna be?
In case A.
Well, no. If I just took this placement table and put 111 here, what's the answer? If I put, rather than 100, I had 111, what would it be?
So,
The largest digit. You understand what I'm saying? So ain't no way you should be able to get an 8 or a 9, you understand? But 7, anything from 0 to 7, right? So that's the only, I'm saying, valid digit that should be there. Anything from 0 to 7, all right? So let me write a number down then. I'll write this number down. Hopefully everybody, let's see, I'll write it here. What is that? And now you gotta watch, because a lot of times if your eyes play tricks on you, yeah, you gotta wipe them zeros and them ones, right? Because it can cause havoc. Because any one misplacement of a number, man, you way off.
Okay, I have a question. I always studied this. It's like math class.
Right, but this is computer science, but this trying to get you to understand computers, how data is stored, and a lot of times when you get error messages, those hex messages, those decimal numbers, hex octal numbers, you understand what you see. You understand? Now, there's always a process behind, like I was telling them, a dump. You know, when you get a dump saying that, oh, at such and such address, given that compiler is a way you got to figure out how to get to where the error is. But when you understand these numbers, you can understand and appreciate what's going on when you get an error with nothing but those zeros and ones and the F's and whatever.
26655.
Okay, come on and work it out up here. All right. So you're gonna start what? From the left, going to the right, right? Excuse me, my fault. Start from the right, going to the left, and dividing it by 3, right?
Yeah.
All right. And what? If you just add a 0. So 101 is what? 411 is 5, right? 411 is 5. That's yep. 26655 in base 8. So you see how quick that was, easy that was, but you gotta know what? The rule.
Do you bother like putting commas or anything?
No, you don't have that. No, just put the number. All right, just the number. All right, everybody got that? Everybody understand that? Understand?
So, when we write down,
Put the
from
base.
right, we do it the opposite way, right?
Right, because, wait, say that again now?
Like when we write down the numbers from working from right to left, we write the answer the opposite way, right?
Well, you can still write the number from right to left, but you know the left is the first number.
So we should start from the left when we're doing the work.
Right, once you done divided it,
Yeah.
you're straight, because you done divided it up and you know the
Right,
different
right.
sections. Right. Yep. Questions? Questions? All right, let's do another one. All right?
That's messed up, man.
Huh?
That's messed up.
No, man. Yep, so just follow the same rules, starting from the right, going to the left, dividing it up. Yeah.
100141.
Alright, there you go, Miss what? Kinda do it. You got it?
Can I have more time to convert it?
Okay, go ahead, yeah, no problem. But you know how we convert it, huh? Just adding up the the switch is on. You got 421. 421. If it's 100, it's 4. If it's 010, it's 2. If it's 011, it's 2 plus 1, it's 3.
I don't get it, it just.
Right, it takes a little time, yeah, but yeah, just practice. A lot of practice. Yeah, it's practice. Alright? Thank you. Alright?
Hardest part for me is writing down all the ones and zeros.
Right, and making sure I don't miss anything, because you miss something and throw the whole thing off.
I do like groups of 3 zeros and then like keep going like that. Like I can track 3 zeros easily.
Yeah, but what if what if I took that first, like 10?
No, like, I mean when I'm writing it down.
Oh, yeah, right. It helps you.
Yeah.
Yeah, stay on track. Yeah, you're right. I see what you're saying. Got it, Miss Jean? Oh, all right. So now let's look at now if this is converting a number to base 8, what you think the process would be to convert a base 8 number to base 2? Which is for every digit I must represent it in what? 3 binary digits. Like 4, I would have to represent it as 100. 2, I'd have to represent it as 010. 1, I'd have to represent it as what?
001.
Right. 0, I have to represent it as?
000.
Correct. So for every digit in the octal number, I have to represent it in 3 binary digits. All right? So that's the rule. We kind of went over the rule. Look here. So what happens? Look here. We have a octal digit, 603. All right? So what they did was they said, okay, let's take the 6 represented in 3 binary digits. 1, 1, which is 4 plus 2, 0. Right? So that's 6. 0, which is just what? 0, 0, 0. 3, which is 2 plus 1, so that's 0, 1, 1. So now we write this, and this down, we get 110, 000, 011. Yes, sir.
I think you have to watch that there because when the number's not going evenly,
No, when you have a hex number, it
so you
will
wouldn't
be
have to worry about filling in zeros ever.
where?
Like just like we said earlier, like if 3 doesn't go into evenly, you would have to fill behind it with zeros.
No, but this is not the same case.
Right.
Every digit will have to have 3 digit binary digits.
See, that's what I'm saying. You won't have to worry about. filling.
Right, you won't have to, correct. Yeah, you won't have to. Now, so you say you understand that, so let's do this then. Let's take this off. Oh, yeah. And I'll say so what would that be? So we have 431102 in base 8. Right.
Yeah, I'll write it down. I don't want to say all that.
Oh.
I use a
That
calculator.
too.
Use a calculator, you can't do that because you got to learn it.
I can write it.
I use a calculator.
I mean, that's why the calculator exists.
No, a calculator. A calculator existed to check you with. No, I don't know. Oh boy. So 4 is what? 100. 3 is what? 011. 1 is 001. 1 is.
I imagine when it becomes the 16, the
Hex?
that's where it gets a little bit more complicated. No?
About the same.
Really?
Yeah. Alright, so now divide it by 3. Okay. So we can kind of look at it. So we know that's 4. We know that's 3. We know that's 1. We know that's 1. We know that's 0. And the last one 2. Right?
Yep.
Just to try to make it look to show you might have an extra 0 or whatever.
Right.
Alright? So everybody see that answer. So let me ask you this. It ain't time to go on, Mr. Fairbanks. It's not time to go. Alright. So this one is a little tricky, class. This 8, no, this is 2.
It's not real.
Oh boy. Why not?
Because 8 can't be in there. Like, because it only goes 0 to 7.
Everybody understand what just happened?
Oh. Okay.
That's not a valid octal number because 8 cannot be a digit in base 8. Everybody understand that? So if you just look through the number and say, oh no, invalid. To 7, right. If I have an 8 down there, it got to be 0 through 7.
Like I said, I'm probably spent there for a half hour.
Right, so you got to that's just like me writing a binary number, and I write something like this. What happens? Error, because 2 is not a valid digit in binary, right? So you got to be watching that. All right. So, how can we take that octal number and convert it to decimal? All right. Let's take a short number. Let's say
Wouldn't you just convert it to binary, then convert it to?
Say 21 in base 8 is equal to what in base 10? How would you convert that octal number to base 10?
Be 3, right?
Huh?
It's not.
7 times 3 equals.
Wait.
Yeah. It's not even 9.
No.
Well, 8 to the 0 is 1. But 8 to the 1, 8 to the 1 is what? 8
Yeah.
times 2 times 2
Wait, it's 16.
plus 1.
It's 7.
Right.
Okay.
Now,
Just didn't do the.
right. So look, what happens is you're gonna have to take that number, and I just have 8 to the 0, 8, 1, 8 squared. So, wait. Right. I just have a 2-digit number, but I could go on, right? So 8 to the 0 is 1, 8 to, this is 8. 8 to the 1 is 8, 8 squared is 64, right? Right. So now, I want to take that number, which is what? 21. correct? I have to take 2 times 8 plus 1 times 1.
I was thinking in binary when I did that.
Right, because I'm gonna show you, let me ask you this question. If I had this number, 123 in base 10, how do I know that's 123?
Because of base 10.
And then how would I know that? This is the what's column.
The ones, the tens, and the hundreds.
So on 100 times 1, 100 times 1
100, yeah.
plus 10 times 2
Is 20.
plus 1 times 3,
It's 3.
123. You got me?
What
So-
if that was 121?
What if this was what?
121, we added it there.
So now you would do 64 times 1 plus 8 times 2 plus 1 times 1.
Oh, so you're multiplying and then you're adding.
Right, just like you just did here. Because what? This is, I'm gonna do the placement table. This is 10 to the 1, which is 1, 10 squared, 10 to the 0, 10 to the 1, which is 10, and 10 squared, which is what? 100. So when I put 1, 2, 3, that's what? 1 times 100 is what?
100.
100, 2 times 10, 20, plus 3 times 1 is 3.
I've never thought about our numbers just being like that in base 10. Like, I've just never thought about
Oh, you never looked at it there. Right. But everybody understands, same concept. Right? So, if I took this number and changed it to like 224 in base 8, what's that in base 10? Do your multiplication, remember your table, 8 to the 0, 8 to the 1, 8 squared. Because I only have 3 digits.
that last one.
Yeah, 224, I think.
What was the number?
224 in base 8. And we convert to base 10.
128,164.
Okay, so you did 2 times 64.
Yeah.
Plus 2 times 16 plus 4 times 1.
Yeah.
Right. That's why, whatever that is.
Yeah.
Right? But everybody, and like I said, that's the process. Right? That's the process. So you can convert from base 2 to base 8, base 8 to base 2, and base 8 to base 10. Now, the thing is I want to show you is, watch. Now, what was that number you had, Mr. What's your name, Mr.
McDowell.
McDowell? Okay, this number is what in base 10? 224 is what in base 10?
I got one.
So you're not sure now?
128,000.
Huh?
I'm stuttering.
Oh, okay.
128,000 and 164. But I'm no longer sure of that.
Who else? What you got?
I got 145, but I mean,
Yeah.
Can you repeat the steps, how you do it? So you multiply and then what do you do?
Yeah, multiply the 2 times the 64. Remember? Like, okay, let me put it here.
Okay.
2 times 64 plus 8 times 2 plus 4 times 1.
I got
So you
128,000.
multiply all that and then just add it together?
No, you can't. What? That multiply this, multiply this, multiply this.
Uh-huh.
Yeah, then add.
And then add.
You're right, but you got to make sure that you got this value plus this value plus this
it'll
value.
be 148.
148.
That's the answer?
Yeah.
That's it?
I forgot to add. I just slapped them all together.
Oh no. So the answer is what?
148.
Just 148. Now, take this 148, convert it convert it to binary. Take 148, remember your table. Find the highest value that's less than or equal to that value, and then put the 1, then keep subtracting, remember? I can show you the table. Let's pull it back up. This the binary table. So find the highest value that's less than or equal to, put the 1, subtract, and then if you're not at 0, keep on doing it. I'm gonna show you something.
Alright.
You got it. Let's see.
I find that I'm struggling to like remember everything.
Yeah, those steps, right? Yeah. Remember the steps. I want to say, go take a little practice. You gotta practice. And once you get it, you're like, oh, okay, it's not hard. It's not hard. It's just knowing what to do.
Yeah. Well, it's like you're learning like multiple things all at once, and then you're like immediately trying to
Put it back.
Yeah.
To apply it. Hold up. You got it, Miss James? Let's see what you got. What y'all compare? What you got?
1 0 0 1 0 1 0 0.
Okay. All right, that what you got?
Yeah.
So I'm gonna write that number down, okay? That's what I'm gonna write, what y'all got, okay? So y'all took 148, which came from octal value 224, right? And came up with a binary value of what?
0, 0, 1, 0, 1, 0, 0.
Right? In base 2. Now, looking at this number in base 8, right? Convert that to binary. What it is? How would I do that?
You would.
Huh?
Do the subtraction.
Not.
Which
I want to take this octal number and convert to binary. Every digit should be represented with 3 binary digits. So I'd have 2 is what? 0, 1, 0. 2 is what? 0, 1, 0. 4 is what?
1 0.
1, 0, 0. What happened here? What happened? I used this to get this, but then this and gave me that, which is the same, right? So everybody, see how you can always check yourself. If I find the binary value in octal, right? Then I should be able to find the decimal value and then take that decimal value and come back and find the binary value of that decimal number. And I should come back to the same what? Same answer.
Yeah, I was gonna say, so our answer was right.
Yeah.
It's at a 0.
Well, yeah, the 0 came because remember every digit should be represented with 3 decimal binary digits. So you see?
Yeah.
And we come up with the same answer. Just 2 different sides.
Back in the day, that just meant like on and off, right?
1 and 0?
Yeah.
Yeah.
So they actually had people
Well, no, It just
turning
was.
off like a light switch.
Well, no, it was like switches that was on and off, and that's how it kind of started. You know, like a bit was on, bit was off, so it knew on off. Yes, no. And then engineering, that's how they gates work, on off. Yeah,
How does that work though? That's like the hardware part?
That's hardware, yeah. That's engineering. That's all that stuff. Right. But with computer science, you had on-off switches, but they just dealt with binary. 0 is off, and 1 is on. Yeah. But it had nothing to do with the switch or nibble. Yeah. They just use it to kind of get you to understand.
Understand
What
what
we're talking about.
Huh? Right, correct.
Oh, we're talking like back in the day, like how did they first get computers to like assign a character to a number? Like,
Variables. So using variables.
yeah.
What in the low level, like I say, in low level language, well, somebody had to, I think, write the compiler. Somebody to write the program. So number one, that's what the first step. Writing the compiler. And like I said, back in the day, you had, and then you pretty much have to have a variable because you wanted to be able to access that information. But what happens is today, which has happened back then, when you wrote a compiler, when I said int x equals 5, you got your computer memory, right? Back in the day, the memory just was there, and you had to pretty much tell it, put it in this memory location. Nowadays, you know, you got certain levels of memory or areas, certain areas for whatever. So now, when you say, okay, int x equals 5, user whatever, so it's saying, okay, somewhere in memory, that's an address. So that address, how would I say it? To just recognize it by numbers is hard, if you understand what I'm saying. If you ask me, well, we could do it with our street addresses, but if you ask me, well, where is that number located? BCAFG. Not G, BCAFD. You know, and I'm telling you an address.
So,
but if I say it's a variable income, like you kind of understand.
so basically, it's like the software working with the hardware because the hardware has the address for it.
Right, the hardware, that memory has to be available.
Yeah.
It has to be. If it's not, because if you have a computer without any RAM memory, it won't what?
Yeah.
Won't come on, right? Yeah.
So when they were programming the compilers, were they just using strictly machine language?
Yes, definitely. And see, that's what I'm saying.
That was took forever.
Right, but it's like, and then you got to make sure you got tests in place to where you can't have people violating and going
And
into.
like all the mistakes too you can make with the zeros and ones.
Right, and if you look at if you look at the way C++ is and the way they have the open source, people take code from other people and kind of enrich it or water down the resource side to have more processing, or to water down the process side to have more resource allocated, you know, stuff like that. But it's already, some portions of it's already built, right? But like you say, yeah, that is a lot. Yeah, that is a lot. Yeah, it's a lot.
I would be a computer science.
Huh?
So I probably want to be a computer science.
Yeah, but and see, that's why, like I said, back in the day, your computer scientists were what? Mathematicians and scientists and whatnot. Yeah. Brainiacs. Nowadays, like I say, little 5-year-old kids, you know, can code stuff because it's icons and whatnot. Yeah.
Well, I was wondering, since the address is within the hardware, how would they then, like, if they wanted that number instead of the letter?
If they wanted that address location,
Yeah, if they wanted the number, like, that the binary had instead of the character address. Like, you understand what I'm saying?
if they wanted to pull that data from the memory.
Yeah.
But I think what computers always did, well, it was addresses though. It was because a similar language, you had to know the address. But then you still had variables. In my day, when we had a similar, we still had somewhat variables, but we still referenced a memory location.
Yeah.
Yeah, you know, you just knew that location. Because see, the person who operated that computer knew it in and out. You know, they knew the ins and outs of it. It wasn't like, okay, I could get on this computer, do whatever, and I'm finished.
They basically just studied.
Period.
Yeah.
That system. Correct.
Got it.
Right.
Got it.
Right.
So like even when we're doing our simple programs, it outputs letters and words, but how do they end up outputting pictures or something like that? Like
Zeros and one. Everything is what? Data. Everything is information. So it puts that information back together. It puts it in the computer as zeros and one.
but when we're playing video games or something, they don't look like zeros and ones. I mean, it looks
Right, correct.
realistic, you know what I mean?
Right. But see that's the computer has to load it in that fashion, but then display it in the fashion of whatever.
So you would actually have to design the art part of whatever.
No, but see, like nowadays, you're not worried about zeros and ones. What you're doing is you design, like say, when I create, if I use some software to create a circle and then fill that circle with a color, I don't have to worry about the zeros and ones. I'm basically dealing with the software to actually make the circle and do the color.
For the zeros and ones, that compiler's already.
When I compile it to make it executable, then the computer takes what I have and make it executable. Because when you try to open up, if you ever try to edit an executable file, like trying to do edit on it, you're gonna get all kind of funny characters, or you might get all kind of beeps or whatever, because it's just all kind of it's a low level language, and we can't understand.
It's like on Visual Studio, you couldn't do something like that, right?
Visual Studio couldn't do what?
Like make games and stuff like that.
Right, because Visual Studio is a package.
Right.
That, and you could create applications using that. Yeah, you could create applications. Because now, in Visual Studio, you got Python you can use, a compiler, Java compiler,
Right.
mobile app compiler. So they got all those different compilers in that Visual Studio that you can add and create applications. Yeah. Right. We just create the one file and that's that. We don't create a large application where it has multiple files, like modules and whatever.
Right.
Yeah. They can do it. They should be able to do it. Now, you might not be able to do an extensive job in gaming and whatnot.
Right.
You probably need another software package for that. Yeah, but that's how it works. So you gotta have memory. You gotta allocate that space. And back in the day, like I said, man, you have to know that system, and that system pretty much was from this wall to that wall, and you plugging in wires to make sure whatever. It's kind of like the the operator, you know, because what she had to patch you in from one person to the next.
Right.
Connectivity and all that, right? All that was key back then. But we advanced. Yeah, we did advance. All right. So now, any questions about converting from octal to binary to decimal back to octal? Any questions? Now, so we went over this. We even went over this, the decimal. See the decimal part? 603, 64 times 6 plus 8 times 0 plus 1 times 3. Add them all up and you got your answer. Here is our hexadecimal table. All right. Now, hexadecimal is how many digits?
16.
16, which goes from what to what?
Zero to F.
0 to F. Now, if you look at this table here, in decimal form, we go from 0 to what? 15. That's the 16. Then, in hex, the valid digits are what? 0 through 3 through 9, then A to F. All right? Because what? Every digit has to be represented in one position, right? So they had to come up with a way to do that beyond the 0 through 9.
So you couldn't do like 1, 0.
Because they're taking up two positions.
You just need that one.
Right. Because when a computer reading a character, you can't say, okay, now 1, 0 is another character. It's just that's two different characters. Now you know we have our escape sequences with the backslash whatever. That says one character.
So I'm just making a guess. Is that what like the 32-bit and 64-bit operating systems is? That like an extended version?
Right, it's an extended version of this. Correct. Because now you can address more,
Yeah.
and you can throw more out at a time, which runs faster.
What do they do after like 32? Do they pull a different language?
Well, what we had with that was, like I say, and to me, personal opinion, I don't think it's going to be an issue of whether or not they can do it. It's going to be whether or not they're going to be able to keep the computer from burning up. If you understand what I'm saying. Because the faster data moves, the hotter, the computer's going to be running. So as that data runs faster, it's going to
Correlation between performance and heat.
Right, that's what I'm saying, they're gonna have to come up with ways to keep your computer cool. And if they can't do that, then they're defeating the purpose, cause what? You build a computer the day to run and then it burns up somebody's leg or somebody leave it on and it burns up their houses, then you got problems. Yeah, I'm gonna give you a quiz.
I mean, couldn't we just use a water cooler?
Well, they do have one, you know, me and my son were talking about
For fastest, that's what we use for nuclear,
Right, but what I'm saying is though, as you go to that,
Yeah.
pressure, type cooler, you understand what I'm saying? You're dealing with biochemistry and all that.
Smarter than us have already thought about it.
Right, you see what I'm saying? So it's a lot that goes into to that development. Now, which come to shove, depending on with the need or whatever, you might try it. Yeah, you might try it.
So with the bits, so they represent storage, right?
The what?
The bits.
The best bike, right, whatever.
That's why, yeah. So there must have been a point where they couldn't, because the hardware wasn't advanced enough to be able to store enough.
Well, no, what it was speed. It was speed. Cause if you notice, they always what? They had the floppy disk.
Yeah.
Then they went to the floppy disk, the 5 1/4. I mean, the 3 1/2. Then the 3 1/2 high density. Then whatever. So the storage, you know, you got terabytes, you know, whatever. So the storage, I don't think is the issue. I think it's speed. You know? And I think too, and that's in my opinion, they gonna gradually move up the speed to milk our money.
Yeah.
You know what I'm saying? So if a computer running so fast at a time, now you're like, okay, I got this fast enough. Move it on up just a little bit. Hey, if a new computer came out, whatever, move it on up just a little. Because if they just go from here to here, they're losing out. You
Is
know?
that why the computers, like, pricing is so much more now than it was?
Well, right. Well, I think it's lower. You know, you get a laptop.
There was that
That's why I'm
crash.
building
with the
your
whole-
own, because I remember
Oh,
building your own was a lot
building
more cheaper than it was.
Oh, yeah.
I was gonna say, there was that crash with the whole Bitcoin fiat, like,
Right.
I don't even know if that's gone down.
I don't know, but Bitcoin at one time, man, there was a big thing on what they call it, the black cybernet. What they call it?
The dot toward that?
Yeah, they used it in the underworld.
Yeah.
They was using it a lot in that.
It's crazy that it got in the news, like, I think at one point it was like $10,000 equivalent, like one
One Bitcoin.
Yeah, one Bitcoin was like, I don't know what it is now, but like, it was up there.
Right. Because people talking about their money gonna be gone. Well, I'll probably be gone for money though. You know, ain't gonna be y'all situation. Yeah, won't be any more money.
You personally ever designed a game?
Huh? No, I normally did databases.
Did you ever do like network pen testing or anything like that?
No, I set up networks or whatever, no, but
Yeah.
You worked at Microsoft, right? No?
No, I work teaching,
Oh, your whole life?
about 30 years.
30 years? Oh,
You ever work for a place that their own like server room?
No?
No?
What places?
But we had our own server, but I worked with Linux servers. When we had
Okay.
we had Linux
Oh,
and we had a Sun server, and we had the Sun machine. Yeah, those servers.
okay.
I've created my own server. I had a web server at home for a good while. From like say the site you log in.
Right.
When I first started, I had it at home, but like I say, I had to maintain it, do whatever, power go out, whatever. I said, then I said I was going to just have it online. Yeah, so I went through GoDaddy and some of these other ones, and then
Got it.
yeah. So because it's less stress on me, you know. I have to keep it up. All I do is modify it to do whatever. But they got
So did you do just be a
Domain.
professor for
Huh?
30 years or doing high school?
Well, no. When I got out, I was a lab tech. I was like PC maintenance, hardware, software, installation, all the repair, all that. I did that from 86 to like 88. Then I started teaching, like adjunct teaching. Then I think around.
So you didn't go and get your PhD and all that?
No, I'm not a doctor. No, I got a master's, but I'm not a PhD.
Okay. So like, what do you think about?
You should get it so people have to call you doctor.
No, too old for that. Too old.
What do you think about gaming? You think that's a bad thing to go into?
I think it's good. See, this is the thing though.
I will say.
A product. If you make a product that people gonna buy, you know, you're good.
But they work like a lot of hours though. I heard
But what I'm saying is,
Yeah.
yeah. But the thing is, okay, you can go into gaming. You can go into gaming and go with a company. Like we had a guy who go work for what, EA Sports, I think, in Florida. You went work with them for a
Yeah.
while. But you could develop your own game.
Games.
Because the thing is,
That's probably the best way
and
to
you
go.
got to look at it. Some people look at it. Okay, well I'm gonna just develop games, and some people look at it as destroy your games or whatever. But man, you know how much money you can make in education. You know, designing games for educational purposes for kids or whatever. Or whatever. You know what I'm saying? But it's still a game. In a sense, it's a game, but
It's for kids.
yeah, you
Right.
you
It's some
think
games that we.
Right. And like I said, it could be a tutorial tool, you know? You don't look at it as a game, you look at it as something that just guide them through, understand
It's
whatever.
kind of what he was saying. It's kind of like the market there, because people will go and take less money for it
That's,
to
yeah,
become a video game.
right.
I'm sure you've heard about like Red Dead and all
Yeah.
that, like whatever hours, like that sounds like.
Yeah, no, they do.
That sounds like burnout though. I mean, it sounds like that.
It could, yeah.
It sounds like it causes more bugs.
Well, they
But
can
Well-
do that too because you're easily replaceable
Yeah,
because there's so
right.
many people.
Well, you have a lot,
Hurt
and,
you, but like,
no,
yeah,
no.
and another thing too, they have large turnover, you know? Yeah,
I
'cause
heard web development is really good.
yeah,
Like
it's
web
good.
development is pretty easy to go into. They work like 40 hours or something. Like that.
Right.
Like a couple of years ago, I was gonna go for video game design, but the more I thought about it, the more I realized that I
Yeah.
should just learn computer science and then as a hobby.
Right, and then move
Yeah,
on
and
to
the
the
gaming
area
on the
around.
side. That's what I was thinking.
Yeah,
about.
And then the thing is though, you never, how would I say, never stop learning. That's one of the keys.
Right.
You know, because you might be working in a area of gaming, but then it might be another area, such as could be videography.
That could help you.
You tap into that because you never know if you might sway into that or use some of that to bring that some live whatever into you whatever. So you know, so as you working in one field, always branch out and learn more to bring it all together. Yeah, and I tell people too. But me, over the years that I've used software, I might sometimes a particular software that does a particular task, I might have 3 or 4 different ones because each one perform in a different way.
Right.
So I need to do one thing, I'll use this one. I need to do something else, I use the other one. But together, they allow me to create what I need to create. So it's always man learning, always whatever.
How many languages do you know? Just C++?
I learned, well, in school, we Pascal. It's been a long time since I
Pascal,
Pascal.
How many do you remember?
Oh, if I look at it, I'll do it. Fortran, Ada, Cobol, all right, and then the C++. Yeah, the Java I'm kind of getting into now.
This guy works
Now
with
I do know how to write in
Pascal.
PHP because my web pages that's PHP with a mixture of JavaScript. Well, I got a little bit of HTML in it too, right? HTML, but see, PHP can mesh with HTML.
Oh, okay.
And what happens is, and now I looked out because it was 2 different ways I could have went. I could have went the Microsoft way or the PHP way, and the PHP way was more secure because if you notice on my pages, many times if you try to look at the source, if I got PHP in the code, it won't show you none of the source.
Yeah.
Yeah, right, yeah.
See, I haven't even.
Right, PHP, yeah, it controls that,
Huh.
yeah.
That's actually interesting.
I wanna ask you
That's good to know. Yeah.
the Visual Studio.
Uh,
Do you have to resave it and save as after you fix your
Check.
mistakes? Because I went and clicked save on that one I did the space and where programming is great fun. Well, the first time I did it, I lost the space. I fixed it and saved it, but it didn't save it. Like I wonder if I have to go back.
Every time you execute successfully, it automatically saves.
Ah, okay.
Anytime you execute
So I had to run it
successfully-
and then.
Right,
Oh,
don't
that's
just say,
probably
oh,
what I
I need a space, put the space and
Yeah, I
then exit
didn't
out.
run it. That's probably what it was.
Right.
Yeah, I put the
But
space
yeah,
in it.
yeah. If you don't ran it, it automatically saved, right.
Because I knew if I put the space there, I was like, okay, it's gonna be fixed. So I just, didn't.
Yeah. But you didn't save it on.
No, I didn't save
Right,
it actually.
right.
I thought I saved it though.
Oh, okay. Yeah, but when you run it, if it executes successfully, it automatically saves.
Do you do teaching like only, or do you do like side jobs where you like make websites or like help with networking or apps?
I don't
or
like-
apps. Yeah.
I don't like to make I don't like to make websites because I tell people once you do a website, you become dependent because you're the call person. You know what I'm saying?
Yeah.
And I don't want to be I got an issue such and such. I got to go with that. I don't like that, but it can be done. My thing now, what I do is I mostly like take photographs and do video and stuff like that on the side. Like at our church, I'll always record my brother's a pastor. I record his sermons and post them on YouTube. I'll do that. And I'll take pictures at every events. But then if somebody said, "Well, could you make a DVD or whatever?" I use Vegas, what it is, Sony Vegas, and I can render a video, pictures and video, right, stuff like that. Yeah,
You ever just like develop software for another company?
I did like databases.
How does it normally go? Do they usually contact like your company and they get a team of you and other software developers to make it? Or can you make a product and sell it?
No, well, what it is, they'll contact me. Okay, somebody say, okay, well, Mr. Lessigan, write a database. So they contact me. We have a meeting. What it is you want, whatever. This is what can be done, how, whatever.
What if you wanted to develop
gotta
a
have this
database
way.
for a company without them knowing about you? They just like, and you just say, hey, I have one for you guys.
Well, now that, but like I say, that's software development in that you're trying to create a product to put on the market.
Yeah, because
That's like creating an app. You don't know if they're gonna take your app or like it.
At LSU, they give you two choices: either data science or it's software
Software
development,
engineering,
engineering, stuff like that.
Right.
So you did more of the data science, like data storaging and stuff like that.
Well, yeah, but
I heard that's more like analytical and like.
see, that's not what I did.
Right.
More or less programming and project management and whatever. Right, and more or less on the business side too. Right.
So what's the biggest difference between data science and like?
See, data science is more or less data science. You can take somebody in the business world who know Excel and maybe SAS, which is a statistical program and whatnot, and take data, analyze it, do whatever.
They're just working with numbers pretty much.
In a sense, and using applications to determine what's going on.
That's not boring though.
But at the same time, if you're a programmer, you can use SQL to write code against that data to give a certain report or whatnot. So you see what I'm saying? The different sides of it.
Yeah.
Right. Because in SQL just says, okay, you have some data. I want to do a report where I want to take this. I want to join this table with this table. I want to collect this. I want to add this to that. So that's SQL.
So you would be working with, if you worked in data science, you would be working with software.
So yeah, somewhat, definitely. Yeah, definitely. Not just straight.
So most of like our majors team oriented.
Correct. Because once you get out, because unless you're working with just a very small company, but if you get out there, you're working in a team. Yes, got to
I
definitely.
heard some of the small companies are pretty crazy. They work like 80 hours. You have to develop it all by yourself.
And because they push for time.
Yeah.
They push for time. And like he's saying,
You got liabilities,
that's
too,
what-
like insurance and stuff.
but that's
like
where the
that.
burnout come in.
Yeah.
Yeah, because you're always pressing for time. Always pressing for time.
My company, they're trying to start
Go
up.
find someone who can.
That's right. Turnover is really
I work for a small company called Southern,
Good hours.
and
Yeah.
they're doing like PLCs or whatever.
That hours.
They program
know.
PLCs,
right.
and they're trying to upstart that, but they're trying to get somebody who can design the whole thing.
Yeah, from just going
from
in
the
and
start.
do it. Yeah.
And they have they're liable for the insurance, and if it don't work or if it don't stop one of the machines, then they don't have
So-
insurance. Then
So they'll be liable for their data. So.
yeah,
Wow. Yeah, nobody gonna want to take that.
Exactly.
Man.
so they're
You
trying
give
to.
me a plain machine where
Yeah.
I can do whatever and create whatever, and you test it. Man, you making me liable
They're
for
pretty,
your
they're
project.
pretty crazy though.
Oh yeah, ooh, that's tough, though.
Yeah.
I don't know who's gonna bite on
They
that.
don't wanna pay nobody either,
That's
so
good
it's-
for a job, I guess, anything like
Who that? Nah, but man, you don't want that, cause even if you be successful, down the road something could happen, you know, and then it fall back some, you know.
I mean, but it's also resume experience too, you know?
'cause
Right,
that
right, well, yeah, you're right.
the
That's
customer's not gonna call the company, they're gonna call you.
right,
And they're gonna go, look, I need
X
my
amount of
money.
years of experience.
right,
What
yeah.
about plants? Would they take new grads like straight out getting their bachelors?
Plant, man, I
And what
don't,
would you even be doing at a plant?
well, this is
I think
what
all
you,
companies, I mean, everything we learn here is gonna be.
right, this is what you gotta understand. Every company has payroll. Every company has a data center.
Right.
Every company has, well, like I said, data and processing, reporting. So
You have to
now
learn
you might not ever see it, you know what I'm saying?
Yeah.
But like right there at Exxon, they got their offices where nothing but the data, whatever, however, they got to kick out reports to the government, whatever. They got to get statistics for the government, whatever. So they got computer science. Then you got IT. The computers got to work. The network has to work. So you got all companies. If you got data, and they fill out big data, you got companies. You got IT staff and networking staff. You got programming staff, development staff, whatever, all that. But it's just that you don't see it on the forefront. And most times, what those companies do, they hire within. You know, 'cause it's like you said, a team.
Work your way up.
Yeah, because they don't want to bring somebody in and now you got a bad vibe with whatever.
Right.
And they say
So your best thing really is to get an internship, so you get on somewhere.
there you go.
Work your way up.
Get that internship. Do what you're supposed to do. Ask questions. Do
I know IBM's like blowing up right now.
right.
So
Do a
people-
little bit. Do above more. And like I said, let them see what you know. You know, show them that you're eager. Oh, yeah.
I used to work in a calibration lab, and I started out as just a runner. I just brought the equipment
There you
to
go.
the labs.
Yeah.
I think
And talking to people and doing whatever. Oh,
I
yeah.
ended up
it
being
does.
So you didn't even start off.
yeah, no,
Coding.
but I ended up being one of the QA people who would go over,
Oh, okay.
and my goal was to be a lab technician, but some stuff happened, so it didn't
Right.
work out.
But he was working his way
Right,
up
just-
to that.
still got
Yeah,
that
get your
experience.
foot in the
Right.
door, yeah.
Right.
But you still got that experience. I mean, you go put that in your
Yeah.
resume, you still.
It does help, I
Yeah.
tell you, man, but you just gotta get
Yeah.
your foot
In the door.
I was like, I don't care if I gotta carry 100-pound.
Right.
Some of it
Because you're
was,
getting paid.
but
Yeah, you're getting paid. Yeah.
Exactly.
So,
And ladies,
So
you
would
need
you- would
contact.
you get an internship as soon as possible? Or would
Yeah,
you
as soon
have
as
to
you
wait?
can.
So you can.
I would say as soon as you available, one come available that you think you can
Do you?
do it.
Yeah.
Yeah. Do
So you think one class of C++ would be?
Could have, yeah, because it all depends on what the company is looking for. Sometimes they want somebody heavy in program. Sometimes they don't. They'll tell you, well, you learn C++, we use an XYZ, but we'll train you.
Right.
You understand what I'm saying? So all you got to do is take the concepts and apply it to.
So that's why you want us to get a resume and stuff like that together.
Right. So because you never know when something is up,
Might
comes
be.
up. Yeah.
I understand. What school did you go to?
I went to Southern.
Southern, okay.
Yeah.
They have a good program?
To me, Southern program is great. And when I was there too, it was great. Cause the way they taught us, man, we had to grind. You
what's
know,
up, man?
labs was open all night,
Yeah.
24/7. We worked, lab whatever.
Yeah.
But they taught you programming. They taught you, how to. And give an example, and I could talk about LSU. At LSU, they got a good program too, but and then UL too, they got a good program.
Southeastern. Because that's where I would probably be.
Yeah, they got one. But
I don't like the way you said that. Yeah, they got one.
no, but I don't know much about it. I don't know much about it.
Yeah.
But at LSU, when our students leave, and then when I had some summer school students, they come like, well, why we got to learn this? Because most of the stuff that they learn over there, it's, I would say, module driven. It's like you're not like we doing logic and whatever. It's not much of logic that the way they teach over there. Right.
So it's just more like operations and stuff like
Right.
that.
Well, it's like, give you an example. My 194 class, I would give a program dealing with sort and search or whatever. And they're like, why are we doing that? Over there, all we got to do is call this whatever, and it does it for us. I say, I understand that, but you should learn how to so that you can understand the inner
So what's
workings.
going on, right?
Right. You know what I'm saying?
It's almost like-
Like
it's almost
out
like-
today, like
huh?
like today when we were learning.
Right, that's what I'm saying, right.
It makes me appreciate that I don't have to.
Yeah.
that much.
Right.
Yeah, seriously.
So that's the only downside.
But it makes
I
you,
have.
understand the computer more.
Right.
Yeah, that it was helpful. Like,
Right. And like I said, that's the only downside I have, is they do that. But other than that,
So it's almost like
they.
they memorize stuff over there instead of actually thinking about doing it.
Well, yeah, they don't do much logical.
Right,
coding.
that's what I'm saying. Even when I do like my practice programs in the book, I'm thinking like, okay, how am I gonna do here?
Right.
Clear my variable, do my pseudocode.
Right.
If I don't do that over there.
Right.
my question is that if I know someone who is a master in computer science and the job that they got, their company says most people copy and paste their code.
Well,
Like how?
that's true. That's true too. Now, what it is, and I tell my upper level classes this. Many times, once you get up there, you're gonna some code. You're gonna copy. You're gonna be like, okay, I'm looking for whatever. Oh, this is some code that does it. Now, you got to be wise enough to fit. It's almost like being a surgeon. Okay, I got a heart here.
Yeah.
Okay, but I gotta be able to stitch it in and make sure everything is working fine.
Okay.
Same with the code. They got variables in that code, they got whatever in that code that I gotta copy that code, put it in mine. I can't just copy and put it and say, oh, it's gonna work.
Yeah.
I gotta
That's what I was wondering,
gotta
because-
gel it to make it work.
Gotcha.
And then
They said you could make like a snake game in
Right.
C++, and I copied and pasted it just to see if it worked. Did not work.
Right, because there's some things you had to
Something
do.
different.
Could have been some drivers. I
Yeah.
won't say drivers, but header files or some function that the other function was calling.
Modules.
That functions module it was calling to do certain things. You understand? So you gotta kind of know that when you're looking through that code. Oh, this module is calling this module.
So you still gotta know it to be able to copy it.
Right. That's what I'm saying. Yeah, you gotta know something.
Yeah. Because I was looking at that, I was like, I have no idea what this is talking about.
Yeah.
I'm hungry, so I'm
Oh, yeah, all right, yeah.
some meat.
I'm gonna be there tomorrow though.
All right.
So.
All right. Yeah.
At work.
Oh, okay. No problem. It's just a bonus.
Okay.
All right.
You have a good one.
Y'all too, man.